Okay, we have page 69, number 4. So we have this rectangle, and we have a bordering isosceles right triangle inscribed in it. And basically the picture shown here. We want to find the sizes of all the other angles. So let's go do a little angle chasing first. Okay, because this is 60, and this is a rectangle, I'll go ahead and just put all of our right angles in here.
It'd all be right triangle. No.
They're all, except for the isosceles, they're all right. Well, the isosceles right triangle. They all are right triangles. What would this angle right here be? 30, because we have a 30, 60, 90 right triangle. And then what about this one right here? That would also be 30 because this is 60 and 90. That adds to 150. Subtract that from 180 and you get a 30 right here. So now we're going around to all of our 30, 60, 90 right triangles. What would this angle here be? 45. It's an isosceles right triangle, so this would be a 45, which means that this triangle, the other angle in that triangle would also be 45. This is a right angle right here, so what would that last angle up on the top left be? 15. And then this bottom right, 75. So we have all of our angles, did a little angle chasing. We have all of our angles there. So now it says, so we went ahead and says find the sizes of other angles. We did that. By assigning lengths to all the segments, you should be able to work out the values for sine, cosine, and tangent of a 75-degree angle without calculators. Okay, well, let's try to do that. If we have, let's start, let's say, maybe let's start here. We'll call this X, and let me change the color here. Let's go, this down here is X. What would this length right here be?
2x.
2x, because it's a 30, 60, 90 right triangle. The hypotenuse is twice the length of the short side. What would the third side of that 30, 60, 90 triangle be? What would this side be? X root 3. So we're going and practicing and remembering all of our ideas from the 30, 60, 90. What about this side right here? 2x, it's the same. What about that right there? X, because that's the hypotenuse. This is the hypotenuse in this 30, 60, 90. So this has to be the short side over here of X. And what about the top side of that whole rectangle? X square root 3. Okay, so far so good. What about this length right here? 2x root 2, because we have an isosceles right triangle here, 45, 45, 90. Then whatever this side, these sides are, times root 2 gives you that hypotenuse. So 2x root 2. Now we get to kind of the harder parts here. We have this side. Let's go to the bottom side. Any ideas for this bottom length right here?
X root 3 minus a.
Yeah, how'd you do that, Clarice?
As the top one is x root 3.
So this is x root 3, and if we subtract this x down here, we would get x root 3 minus x. So I'll try to write that here. X root 3 minus x. Okay, the same idea we can use for this side. What would this side be? X plus x root 3. Okay, so now the whole goal is to find the sine, cosine, and tangent of a 75-degree angle. So here's our 75-degree angle. Let's try sine 75. What is the opposite side of our 75-degree angle? X plus x root 3. So sine is opposite over hypotenuse, right? So we'd have x plus x root 3 over, what's the hypotenuse of this triangle? 2x root 2.
You have to work that out?
Yeah, we don't want any x's in there. So what can I do with the x's in the numerator here? Any ideas? We have x plus something times x. What if I take the x and factor it out in front? What would be left? Close. You'd have plus root 3, but you divided an x out, so you'd have 1 plus root 3. That makes sense? So I just factored my x out of this, brought it out in front. Now, see, if I redistributed, I would have the x plus x root 3. Okay, and then that's divided by 2x root 2. Well, now since it's multiplied, I can go ahead and divide out the x's. X divided by x is 1. So my final answer for sine 75 is 1 plus root 3 over 2 root 2. And that's a number. It's a yucky number, obviously. But if you did that number in your calculator, 1 plus root 3 divided by 2 root 2, and then you did sine 75, they'd be the same. So we can do the same idea with cosine and tangent. So cosine 75, what's the adjacent side to 75?
X root 3 minus x.
X root 3 minus x over the hypotenuse, which is the same thing. We can basically do the same thing here. We get root 3 minus 1 over 2x root 2. Cancel those. Root 3 minus 1 over 2 root 2. Similar to this, that's kind of interesting. So there's our sine of 75. There's our cosine 75. And let's finish with tangent of 75. What's your opposite side of 75?
X plus x root 3.
X plus x root 3. And your adjacent side?
X root 3 minus x.
There we go, Connor. Good. And then we can factor those again.
Would be
Cancel those out. And then our final answer, we could actually even, well, we could just go 1 plus root 3 over, let's go negative 1 plus root 3. It just looks kind of,
uniform.
yeah, it looks cool. And that'd be tangent 75. Yes? If I wanted to simplify these out further, you probably shouldn't have these radicals in the denominator. So we would do some more, but I definitely just wanted to get the idea of how we would solve a problem like this. Maybe on a test, probably not. This is a complex idea, but it's a good practice for trig functions.